Hello everyone, welcome back to A4 Analysis YouTube channel. We are starting a new series where we will be revising few of the topics related to data science and we are starting with statistics. So we are starting with the very basic concepts, and the idea of this series is I will go through few of the books to brush up my topics to understand the subjects even better, and along with that, I will try to make small videos so that I can highlight few of the important things from those chapters so that you guys can study with me, brush up these topics with me, or just have a quick revise. So today's topic would be Introduction to Statistics. The book I am going through right now is Business Statistics by Ken Black. So you guys can check out this book as well. So this is not like a tutorial or anything. I would just talk about few important things from the chapter that I have gone through, and probably that can be helpful in some ways or the other. So without further ado, let's start with the first question, that is, what is business statistics? Now, every minute of the working day, decisions are made by businesses around the world that determine whether companies would be profitable and growing or whether they will stagnate and die. Most of these decisions are made with the assistance of information gathered about marketplace, the economic and financial environment, the workforce, the competition, and other factors. Such information usually comes in the form of data or is accompanied by data. Business statistics provides the tools through which such data are collected, analyzed, summarized, and presented to facilitate the decision-making process. And business statistics plays an important role in the ongoing saga of decision-making within the dynamic world of business. So basically, business statistics will provide us with all the tools to collect this kind of data, to analyze, to summarize, and to present these ideas so that we can make important decisions in the business. Moving on, let's talk about a few of the basic statistical concepts. First one is population. Population is a collection of persons, objects, or items of interest. The population can be a widely defined category, such as all automobiles, or it can be narrowly defined, such as all Ford Mustang cars produced from 2002 to 2005. Then, let's talk about census. When researchers gather data from the whole population for a given measurement of interest, they call it a census. Then, what is sample? A sample is a portion of the whole, which is the population, and if properly taken, is representative of the whole. Now let's talk about descriptive and inferential statistics. Now, study of statistics can be subdivided in two main areas, descriptive statistics and inferential statistics. Descriptive statistics result from gathering data from a body, group, or population and reaching conclusions only about that group. On the other hand, inferential statistics are generated from the process of gathering sample data from a group, body, or population and reaching conclusion about larger group from which the sample was drawn. So descriptive statistics is the case when we are gathering data for all and we are commenting about all of the entities. But inferential statistics will be the case when we are gathering data just for a smaller sample, smaller number of entities instead of taking all the entities, and then we are commenting about the entire population. So in that case, it will be inferential statistics. Then let's talk about parameter and statistic. Parameter is a descriptive measure of the population, and parameters are usually denoted by Greek letters. Some of the examples will be population mean, which is denoted by mu, population variance, which is denoted by sigma square, population standard deviation, which is denoted by sigma, and so on. A descriptive measure of a sample is called a statistic. Statistics are usually denoted by Roman letters. Example of statistics are sample mean, which is x bar, sample variance x squared, sample standard deviation s, and so on. Now let's talk about data measurement. So data measurement in common can be in 4 levels: nominal, ordinal, interval, and ratio. The lowest level of data measurement is known as nominal level, and numbers representing nominal level data, the word level is often omitted, can be used only to classify or categorize. Then we have ordinal level, which is higher than the nominal level, and in this case the data will have certain kind of an order. So that's why it's called as nominal. Then we have interval data. Interval data measurement is the next to the highest level of data in which distance between consecutive numbers have meaning and the data are always numerical. The distances represented by the differences between consecutive numbers are equal. That is, interval data have equal intervals. Such as temperatures, like with Fahrenheit temperature numbers, the temperatures can be ranked and the amount of heat between two consecutive readings such as 20 degree, 21 degree and 22 degree are same. In addition, with the interval level data, the 0 point is a matter of convention or convenience and not a natural or fixed 0 point. 0 is just another point of the scale and does not mean the absence of the phenomenon. So 0 degrees does not mean that Fahrenheit is not the lowest. 0 degrees Fahrenheit is not the lowest possible temperature, but it's just another measurement. Then we have ratio level. Ratio level data measurement is the highest level of data measurement. Ratio data have the same properties as interval data, but ratio data have an absolute 0. The ratio of two numbers is meaningful. The notion of absolute 0 means that 0 is fixed. The 0 value in the data represents the absence of the characteristic being studied. The value of 0 cannot be arbitrarily assigned because it represents a fixed point. The definition enables statisticians to create ratios with the data. Because interval and ratio level data are usually gathered by precise instruments often used in production and engineering processes, in natural standardized testing, or in standardized accounting procedures, they are called metric data and are sometimes referred to as quantitative data. So that's about the first chapter that I have gone through. It just talked about some of the statistical concepts and in general basically gave us an idea about what statistics is about and what are some basic terminologies. And so in summary, we can Say like statistics is an important decision-making tool in business and is used virtually in every area of business. Here we talked about two different types of statistics, descriptive and inferential statistics. Descriptive statistics result from gathering data from a body, group, or population and reaching conclusions only about that group. Inferential statistics are generated from the process of gathering sample data from a group, body, or population and reaching conclusions about the large group from which the sample was drawn. Then, appropriate type of statistical analysis depends on level of data measurement, which can be of four types. We already talked about this. Number one is nominal, number two is ordinal, number three is interval, number four is ratio. Nominal is the lowest level, representing classification of only such data as geographical location, sex, or social security number. The next level is ordinal, which provides rank ordering measurements in which intervals between consecutive numbers do not necessarily represent equal distances. Interval is the next highest level of data measurement in which the distances represented by the consecutive numbers are equal. The highest level of data measurement is ratio, which has all qualities of interval measurement, but the ratio data contain an absolute zero, and ratios between numbers are meaningful. Interval and ratio data sometimes are called metric or quantitative data. Nominal and ordinal data sometimes are called non-metric or qualitative data. Two major types of inferential statistics are parametric statistics and non-parametric statistics. Use of parametric statistics require interval or ratio data and certain assumptions about the distribution of data. The techniques presented in this text are largely parametric. If data are only nominal or ordinal in level, non-parametric statistics must be used. So yeah, that's about today's study with me. Today's topic was introduction to statistics. So thanks for sticking by this video, and we will meet again very soon. Bye guys.